Carnicella, and we are into the next phase of calculus, which is antiderivatives. So I'm just going to get our toes wet and I decided on just doing some basic examples this week. And I'm just going to start out with telling you a little bit of what the antiderivative is. So if you look here, if I started out with x squared and I took the derivative of it, it would be 2x. But what if I wanted to start with 2x and see where it came from? Where did this 2x start from? It would be like going backwards or doing the opposite, and it would be what's called the antiderivative or the integral. And that's the sign that we use for the integral, okay? It looks like a really long S. And to do it, you'd go backwards. So in this case, if I started out with 2x, f of x, or I'm sorry, if the derivative is 2x, then what would the original be? Well, I would know because if I took the derivative, I got 2x. So then I would go backwards and put the 2 up here, and that would be the antiderivative, which is the original function in this case. And that would be x squared. This could have been x squared plus 1. It could have been x squared plus 2. It could have been x squared plus 3. Because when we took the derivative of this part, it would end up being 0, and we wouldn't have shown it. Okay, so you have to say it was x squared, and it was plus some constant. We don't know what it is, so we just put c. And that's important, and you know, it's something that I have to try and remember every time when you're taking the antiderivative to put that c there. So what if I said derivative was x squared? Then what would the original or the integral or antiderivative be? Do you think that you can guess or try and see what you think it was? So in this case, okay, so I know this must have started out, I minused 1 to get that. So it must have been, I'd have to plus 1 to see what it started out as. So I know that it was x to the third power. Then I multiplied something by 3 and got 1. Because this is like a 1x squared. I got that, and I multiplied it. So it must have started out as a 1/3 to get you where you are. I'm trying to find out different things in my head. Like I'm just trying to trial and error it. So that must be what f of x is, but let's remember to put plus some constant. Now, if you have a longer problem like this one, it's kind of like when you take the derivative here, it's kind of like the sum and difference rule. You'll take it of each one. And what I'm going to do is I'm going to erase all this other stuff and move this up. Okay, so that looks better. And with this, I've applied the rule that we came up with. So to take the derivative, you minus 1 from the exponent. In this case, you plus 1 because you're doing the reverse. So you're going to plus 1. And you had initially multiplied by that power, but now you're going to divide by your new power. Don't forget, or actually always remember, I'd rather say it that way, always remember your plus c. And this should be in parentheses with px. So the derivative of a number, or of x, the nth power with respect to x, is equal to x to the n plus 1 over n plus 1 plus c. So just kind of memorize how to do it. So we'll do this first one. The derivative of x to the third. All right, so I'm going to take each one. I'm not the derivative, the antiderivative. I'm going to take the integral of each one. So that's going to be, all right, I'm going to add 1 and then divide by that, what I got. Just something to think about. What if I said, what's the derivative of that? What's the derivative of x to the fourth? If I wanted to go backwards, I would go, all right, you multiply times this, so that would be 4 times 1/4, because this means 1/4, and that gives you 1. And then you would minus the 4 here, and you'd get, so you'd end up with 1x to the third, or just x cubed. Just a real quick showing you that the reverse, why it's the reverse. All right, so that's that part. And then you're got to remember the plus c. Plus c. I'm just going to put it here because this is a little bit different because we have this whole thing. All right, so that is plus c. But we're going to wait to write that down. And then you have minus. All right, so now we're going to do it again. And this is kind of like the, I don't remember what rule it is, but you can pull this out, the 6, and just work with the x squared first. So you'd have 6, and then in here you'd have x to the third, because you're going to add 1 over what you got when you added 1. And then that we'll clean that up in a little bit. And then you got plus c. But I'm not going to write it yet because I'm going to explain why in a second. Plus, now this is like x to the first, right? We all know that's the x to the first. So that's going to be x to the second, because you're going to add 1 over what you got when you added 1. And then it's a plus c also. And this is like, there's a rule. It's easier for me to just think of this as 1x to the 0 power. So for me, it is easier to think, okay, this is x to the 0. So I'm going to add 1 to 0. That gives me 1. So that's x to the first power over 1, or just x. And this should not have, I should not have put this integral here. Sorry. And then plus c. We don't know what this constant is, or this constant, or this constant, or this constant, but if we had written them all out, we would have collected like terms because they were all constants, and we would have gotten some constant. And that's why we don't write it each time, because eventually you end up with a constant. We don't even know what the constant is going to be, so it's not going to matter. We just write plus c. So let's go ahead and clean it up. So that's x to the fourth over 4 minus 6x to the third over 3, which is 2x to the third, right? Because 3 goes into 6 2 times, plus x squared over 2 plus x plus c. And that's your answer. So I'm just going to stop that here for this week. And if you have any questions, please reach out to your teacher. And next week we'll be getting into how to actually solve more difficult derivatives and some other rules, or integrals and antiderivatives, and some rules on how to do so. Be great.